Hi, hello everyone. Welcome back to my YouTube channel Sporifii Learn. Today I'm here with the most requested subject that after I upload DBMS was Discrete Mathematical Structures, that is DMS Module 1. Let's discuss without further wasting time. If you're watching my channel without subscribing, make sure to subscribe and then watch the video. We'll fastly start without further wasting time. See, first I'll be explaining the concepts and then I'll be covering the numericals also. I'll be dividing this module as part 1 and part 2 video because this is a huge concept module, but I'll be uploading the part 2 video also as soon as possible. And DBMS Lab 1 program is also upcoming video. Please stay tuned for the upcoming videos. First, there is logic, that is method of reasoning. Logic is expressed. What does logic means? Method of reasoning. Logic is expressed in symbolic language is called mathematical logic. This is one of the important. And next comes is the important definition, that is of proposition. What is a proposition? It is one statement, adu one statement anta illa declaration which is given in a context can be said to be either ಟ್ರೂ ಆರ್ ಫಾಲ್ಸ್. ಇದನ್ನ ನಾವು ಐದರ್ ಟ್ರೂ ಇಲ್ಲ ಫಾಲ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು, ಬಟ್ ನಾಟ್ ಬೋತ್. ಟ್ರೂ ಮತ್ತೆ ಫಾಲ್ಸ್ ಎರಡು ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ, ಆರ್ ಅಂತ ಹೇಳಿ ಹೇಳ್ಬೋದು. ಬ್ಯಾಂಗ್ಳೂರ್ ಇಸ್ ಇನ್ ಕರ್ನಾಟಕ, ದಿಸ್ ಇಸ್ ಟ್ರೂ ಸ್ಟೇಟ್ಮೆಂಟ್. ನಾವು ಇದನ್ನ ಟ್ರೂನು ಆಗ್ಬೋದು ಫಾಲ್ಸು ಆಗ್ಬೋದು ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ, ಓಕೆನಾ. 7 is divisible by 3, this is false. You cannot say it is true also, it is false also. That is not possible. See, xy is equal to yx. For this, we cannot decisively say whether it is true or unless when we know the value is what of x and y. Here if it is 2 and 3, here it is 3 and 2, it is fine. Here if it is 2 and 3, here it is 5 and 2, it's not same, right? So that is not a proposition in that case. I hope you are getting. Though there are usually represented by small letters such as PQRS and all. You can see this theory part. I'll be explaining just the concept which is important. If you want the same notes, you can DM me on Instagram. Logical connectives. Logical connectives means the words like not, and, if, then, if and only if. Such words are called as logical connectives that connects one word with another word. This is one word, this is one word means it connects the one word to another word. Next is what is compound proposition. First we discuss what is proposition. Now see what is compound proposition. That will combine two given proposition, okay, using the logical connectives. It may use either and, not, if and only if then, like that, and it is called the compound proposition. If it is simple, it does not contain any logical connectives. It is simple as possible. Next is about the negation. A proposition that is obtained by inserting the word not in an appropriate place is called the negation. That is, not means you represent by the symbol. Okay, the proposition p is to 3. 3 is a prime number. Okay, you represent it by 1. Not p is what? 3 is not a prime number. You represent it by 0. So what you will have 1 for 0 and 0 for 1. That means the opposite value you have to be written. Next, the same way for 0 it is 1 and for 1 it is 0. Conjunction. Here in this, what is conjunction means? And. Okay, that is obtained by and. Okay, that you have to remember. If you know the and table that comes in DDC also, you are studying, you have studied that. If you know, you can easily understand this truth table. 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1, except 1 and 1 all are 0. You have to remember like that. Next is disjunction. Disjunction means or. Okay, or between two proposition. Here also you can remember the or truth table. That means if one is true, all are true. Okay, one is true, right? If one input is true, the output will be true. Next is exclusive disjunction. This is nothing but it is as either or. It is used as either or. Okay, that is the symbol you use here is like a reciprocal of k. ಕೆ ರೆಸಿಪ್ರೋಕಲ್ ಥರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ನಿಮಗೆ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ 0 1 ಇದ್ದಾಗ 1 ಇರುತ್ತೆ, 1 0 ಇದ್ದಾಗ 1 ಇರುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಎರಡು ಸೇಮ್ ಇನ್ಪುಟ್ ಇದ್ದಾಗ ದ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ 0. ಓಕೆನಾ, ಇಲ್ಲಾಂದರೆ 1 ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕಂಡೀಷನಲ್. ಕಂಡೀಷನಲ್ ಅಂತಂದರೆ ಏನು? ಇಫ್ ಮತ್ತು ದೆನ್. ಇಫ್ ಪಿ ಇದಿದ್ರೆ ದೆನ್ ಕ್ಯೂ ಇದು, ಆ ಥರ ಏನೋ ಒಂದು ಕಂಡೀಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಓಕೆನಾ, ದಟ್ ಯು ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಲೇಟರ್ ಎವ್ರಿಥಿಂಗ್. word if then we will use here. What is the truth table here is ಎಲ್ಲ truth table ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. better you write it in a sheet of paper. See, 1 0 ಬಂದಾಗ 0, ಓಕೆನಾ. ಸಿ ಹಿಯರ್ 0 ಬಂತಲ್ವಾ, ಸೊ ಇದೇ ಔಟ್ಪುಟ್ ಅಂತ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಬೇರೆ ಎಲ್ಲ ಒಂದಿರುತ್ತೆ. ಬೈ ಕಂಡೀಷನಲ್ ಅಂದರೆ ಇಫ್ ಆ್ಯಂಡ್ ಓನ್ಲಿ ಇಫ್ ಅಂತಂದರೆ ದ ಟೂ ಆರೋ ವಿಲ್ ಬಿ ಫಾರ್ವರ್ಡಿಂಗ್. ಹಿಯರ್ ಇಫ್ ಯು ಸಿ the truth table, that means if the same truth values are there 1 1 0 0, it is true when both p and q have the truth table. It is true, they both have 1 1, rest all 1 0 1 0 have 0 0. Okay, this is the here, and again you can see conditional, biconditional, sorry it is repeated. Okay, now yeah, you can see here for 0 0 it is 1 1 1 it is 1, for rest all it is 0 0. Here it is given combined truth table, you can see this, the conditional, biconditional, disjunction, conjunction, and all everything it's been given here. Now let's come to the problems. Let p a circle is a conic, q is root 5 is a real number, r is exponential series is convergent. You have to express p and not q. Okay, p and not q I will just explain 2 or 3, next you will be seeing. Okay, see p na hange barkoli, a circle is a conic. Okay, there is no change. And add ಮಾಡ್ಕೊಳ್ಳಿ, ಅಂದರೆ ಇದು ಯಾವುದು conjunction. And what you have, negation of q, ಅಂದರೆ root 5 is a real number ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, you have to make it as root 5 is not a real number. That's it. Okay, that is simple, as you know. Next is negation p or q. Okay, this is what disjunction, ಇದೆಲ್ಲ ನೀವು ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. A circle is not a conic because they have given conic, you are making a negation p, and root 5 is a real number and you are adding or, that is disjunction you are adding. Next here what you are using, either or. You know this symbol, right? I hope you know. Here we have been discussed exclusive disjunction. Okay, that the symbol you are using here again, either you have to add or you have to add. Either a is a conic, that means p statement, negation q, that means 5 is a real number. Okay, either or but not both, ಎರಡು ಆಗಕ್ಕಾಗಲ್ಲ, they have given negation, so you have to make it as not a real number. Okay, the same way you can see all the problems. If it is biconditional, you will use if and only if. Okay, if and only if, and if then if you will use, that is how you will see here. Next, the second question is, combine the truth table for the following compound proposition p and negation q. You have to first write p, q, negation p, negation q. They have asked p and negation q. First you have negation q and you have p. Okay, you have to do here and here, you have to just remember these two, and it is and. So if the output is 1 and 1 ಬಂದ್ರೆ ಔಟ್ಪುಟ್ ಏನಾಗಿರುತ್ತೆ 1, ಇಲ್ಲಿ 1 and 1 ಇದೆ, ಸೊ ಔಟ್ಪುಟ್ 1, ಇನ್ನೆಲ್ಲೂ ಇಲ್ಲ, ಸೊ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ 0. ದ ಸೇಮ್ ವೇ ಯು ವಿಲ್ ಸಿ negation p or q. negation p or q ಅಂದರೆ ಇದು ಎರಡು ಟೇಬಲ್ ನೋಡಬೇಕಾಗತ್ತೆ, 1 ಇದೆ 1 ಇದೆ 1, ಇಲ್ಲಿ 0 0 0, ಅಂದರೆ 1 ಇನ್ಪುಟ್ 1 ಇದ್ರೆ 1 ಬರುತ್ತೆ, ಸೊ ಇಲ್ಲಿ 1 ಇದೆ 1. The same way you will construct the truth table here. Next, let p, q, r be the proposition having the values 0, 0 and 1 respectively. You have to find out the truth table values. That is, p have the value, p is equal to 0, q is equal to 0, r is equal to 1. Okay, 0 or 0 or 1. Okay, 0 or 0 is what? 0 or 1 is what? 1. Okay, 1 input is 1 also, it is 1 or condition. Next is the same way, and you will substitute the conditional statement, you will get it as 1. So that's why I said you have to study the truth table, means you can answer all of these questions. And this is also the same, you have to construct the truth table for the p and q, that by conditional, negation, r. Okay, and the second problem also. Next comes about the tautology, contradiction, contingency and all. What is tautology? Tautology means a compound proposition which is true for possible truth values of the components. That means when you have some proposition or the statement which is given that is true for all the statement, that is truth values, that is called tautology. When it is false, it is called contradiction. When it can be said either true or false depending upon the values, it is said to be contingency. Okay. You can see here contingency is neither tautology nor contradiction. It is the compound proposition which is neither that. Okay. See here you can see prove that any proposition P or negation P is tautology and P and negation P is a contradiction. ಅಂದ್ರೆ tautology ಅಂದ್ರೆ ಏನು, ನೀವು ಟ್ರೂತ್ ವ್ಯಾಲ್ಯೂ 1 ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಅಂದ್ರೆ ಟ್ರೂ ವ್ಯಾಲ್ಯೂಸ್ ಅಂತ, ದಟ್ ಇಸ್ 1. ಇಲ್ಲಿ ನೀವೇನಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಫಾಲ್ಸ್ ಅಂತ, ದಟ್ ಇಸ್ ಮೀನ್ 0 ಅಂತ ಹೇಳಿ ನೀವು ಪ್ರೂವ್ ಮಾಡ್ಬೇಕಲ್ವಾ. ಸೊ ವಿ ವಿಲ್ ಸಿ ವಾಟ್ ಡಸ್ ಇಟ್ ವರ್ಕ್ಸ್. ಸಿ ಪಿ ತಗೊಂಡಿದ್ದೀರಾ, ನೆಗೇಷನ್ ಪಿ ತಗೊಂಡಿದ್ದೀರಾ, ಪಿ ಆರ್ ಅಂಡ್ ನೆಗೇಷನ್ ಪಿ. ಓಕೆ, 0 1 ಇದೆ, 1 1 0 ಇದೆ, 1, ದಟ್ ಇಸ್ ಆರ್ ಕಂಡೀಷನ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಆರ್ ರೈಟ್, ದಿಸ್ ಇಸ್ ಆರ್. and ತಗೊಂಡಾಗ ಇಲ್ಲಿ 1 1 ಎಲ್ಲೂ ಇಲ್ಲ, ಸೊ ಆನ್ಸರ್ ವಿಲ್ ಬಿ 0. ದಿಸ್ ಇಸ್ ಪ್ರೂವ್ಡ್ ಆಸ್ ಟ್ರೂತ್ ವ್ಯಾಲ್ಯೂಸ್, ದಟ್ ಇಸ್ tautology. This is proved as 0 0 values, that is contingency. Hence it is proved. Contradiction, sorry, it is not contingency, it is contradiction. Sorry guys. Next is show that for any propositions P and Q, the compound proposition P conditional P or Q is tautology and compound proposition this is contradiction. See here you can see, just substitute the values, find out the and value and apply the conditional statement. You will get all the values as 1, that means that is tautology. And here it is got 0, that is contradiction. Here you can prove that. Here also the same way you can prove, if you do all the operations one by one, you will get all the values as 1. If they say that prove that it is tautology, that means you need to understand all the values which you get in the opposite side will be 1. That is in the answer. This is one of the important, most repeated problem. P or Q, P conditional R, Q conditional R is tautology. Just do one by one. You will get the answer. Same again, it is tautology, contradiction, contingency. See, first doing tautologies you got, doing contradiction you got. Contingency is nothing but mix of zeros and ones you will get. It is neither tautology nor contradiction. Both the mixed values you will get. That is called contingency. That's all. If you see the next topic, that is about the logical equivalence. That means two propositions U and V, if you consider, are said to be logically equivalent whenever U and V have the same truth table values. Okay. When they have the same value, it is said to be logical equivalence. Okay. You have U, that is equivalent means you use this symbol, that is equal to V. Okay. That will be used, and if it is equal, that is said to be always tautology. See, first you can see here P or Q conditional R. You do that first. P or Q conditional R got 1 1 0 1 0 1 0 1. Okay. Now you have to do P conditional R, Q conditional R and operation. Here also you got 1 1 0 1 0 1 0 1. The same values. Here you can compare all the values. All are same. So you can say it is logically equivalent, and it is tautology also. That is, if it all have one values, as it is having zeros and mix, it is what? Contingency condition, as I hope you know. Here what they have said is, if they have U and V are logically equivalent when that is conditional, biconditional statements. Okay. Here it is conditional. Next, examine whether compound proposition is logically equivalent. That means you will be having this value and this value. If you get the same, that means you will just apply the operation. If you get both the value as same, you will be just saying that as logically equivalent. And you can try this for also. Next is loss of logic. That is, first you have double negation. That is, negation of negation P will give you what? P. That means negation and negation will get cancelled. Idempotent law, that is P or P, that will be P. P and P, that will also be P. That is idempotent law. This you have to remember. And identity law is P or F naught, that is P, P and T naught, that is P. This is tautology, and you can see here inverse law, that is P, or negation P is tautology, and P or negation P is F naught, and determinate domination law, commutative law, absorption law, De Morgan's law. This is one of the important negation of P or Q, that will give you negation P or negation Q. See here, or changes to and, okay, and the negation will apply for both here and here. The brackets will get open. Here it is or, here it is and, here it will become or. The symbol opposites. Associative law, you know, distributive law, you know, and for the conditional, if you have P conditional Q, that is negation P or Q, okay, it's not negation P or negation Q, it's negation P or Q. And you can see the proofs for this. Let's solve the problems. Okay, when we have the problems, we can understand it clearly. Prove that it is logical equivalence without using truth tables. See, for this you can apply the truth table also by applying or, and again, or by applying the biconditional, but you don't have to apply the truth table. Just by these laws you have to say that whether it is a logical equivalence or not. See, you will take P or P and P or Q. Okay, that will give you what? P or, this is all is equal to P. P or P is what? P. Due to absorption law and idempotent law. That is logically equivalent. And here also you can see P or Q or negation P and negation Q and R. If you apply the De Morgan's, you know this or, it will be changes to and this negation will be applied for both of these, and you will get by inverse law and associativity, you will get P and or Q or R by identity law. Next, again, these type of problems you can solve. Next comes is you have to just simplify using this laws of logic. Even I have mentioned what is these laws which is used here, identity, inverse. If you just see those laws, you can easily score. This is one of the 20 on 20 scoring module 1. You can easily score this, guys. No need to worry at all. And DMS, you will think that it is tough, but it's not at all. Next comes is another most important topic, that is about the duality. What is duality? First, let's understand. Suppose U is a compound proposition anta heli tagondo, is duality, it's replacing, that is U and ಮತ್ತೆ or na ನೀವು or na and ಇಂದ and ನ or ಇಂದ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತಂದ್ರೆ ಇಟ್ ಇಸ್ ಡ್ಯುಯಾಲಿಟಿ. ಟಿ ನಾಟ್ ಅಂಡ್ ಎಫ್ ನಾಟ್ ನ ಟಿ ನಾಟ್ ನ ಎಫ್ ನಾಟ್ ಇಂದ, ಎಫ್ ನಾಟ್ ನ ಟಿ ನಾಟ್ ಇಂದ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತಂದ್ರೆ ಡ್ಯುಯಾಲಿಟಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಾನ್ವರ್ಸ್ ಅಂತಂದ್ರೆ ಪಿ ಕಂಡೀಷನಲ್ ಕ್ಯೂ ಇದ್ದು ಕ್ಯೂ ಕಂಡೀಷನಲ್ ಪಿ ಆದ್ರೆ ಕಾನ್ವರ್ಸ್, ದಟ್ ಇಸ್ ಅದ್ರದ್ದು ರೆಸಿಪ್ರೋಕಲ್ ಅಂತ. ನೆಗೇಷನ್ ಪಿ ನೆಗೇಷನ್ ಕ್ಯೂ ಆದ್ರೆ ಇನ್ವರ್ಸ್ ಅಂತ. ನೆಗೇಷನ್ ಪಿ ಅಂದ್ರೆ negation q, that is interchanged adre values conditional statement idu contrapositive. Okay, that is having the converse, inverse and contrapositive. Rules of inference ನೀವು ನೋಡ್ಕೋಬಹುದು. I'll be explaining next about the conjunctive simplification. For any two proposition p ಮತ್ತೆ q ಅಂತ ಹೇಳಿ ತಗೊಂಡು p and q ತಗೊಂಡು, if p is true, p and q is p. Okay, you already know these laws. And ಅಕಾರ್ಡಿಂಗ್ ಟು ಡಿಸ್ಜಂಕ್ಟಿವ್ ಅಂತಂದ್ರೆ ಏನು, ಆರ್ ಅಂದ್ರೆ ಏನು, ಪಿ ಆರ್ ಕ್ಯೂ ಇದ್ರೆ ಪಿ. ಸಿಲಾಜಿಸಮ್ ಅಂತಂದ್ರೆ ಏನಾದ್ರು 3 ಪ್ರಪೋಸಿಷನ್ ತಗೊಂಡು ಪಿ ಕ್ಯೂ ಆರ್, ಇಫ್ ಇಟ್ ಇಸ್ ಪಿ ಕಂಡೀಷನಲ್ ಕ್ಯೂ ಇಸ್ ಟ್ರೂ, ಕ್ಯೂ ಕಂಡೀಷನಲ್ ಆರ್ ಇಸ್ ಟ್ರೂ, ದೆನ್ ಪಿ ಕಂಡೀಷನಲ್ ಆರ್ ಇಸ್ ಆಲ್ಸೋ ಟ್ರೂ. ಹಿಯರ್ ಇಟ್ ಇಸ್ ಮಿಸ್ಡ್ ಔಟ್. ಪಿ ಕಂಡೀಷನಲ್ ಆರ್ ಇಸ್ ಆಲ್ಸೋ ಟ್ರೂ. ಓಕೆ, ಸಿ ಇಟ್ ಇಸ್ ಲೈಕ್ ಎ ಬಿ ಬಿ ಸಿ ಅಂದ್ರೆ ಎ ಸಿ, ದಟ್ ಇಸ್ ಲೈಕ್ ಅ transitive. Okay, transitive syllogism. Okay, now this you can see here pq qr pr. Okay, this is the syllogism. Modus ponens nodidre, this is one of the important. See, when you have p is true and p is true, then q is true. ಅಂದರೆ ಪಿ ಆ್ಯಂಡ್ ತಗೊಂಡು ಪಿ ಕಂಡೀಷನಲ್ ಕ್ಯೂ ಇದ್ದರೆ ಅದು ಕ್ಯೂ ಆಗುತ್ತೆ. ಯು ರಿಮೆಂಬರ್ ಎಸ್ ಪಿ ಆ್ಯಂಡ್ ಪಿ ವಿಲ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್, ದಟ್ ಇಸ್ ಕ್ಯೂ ವಿಲ್ ಬಿ ರಿಮೈನಿಂಗ್. ದಟ್ ಇಸ್ ವಾಟ್ ಪೊನೆನ್ಸ್. ಟೊಲೆನ್ಸ್ ಅಂತ ಇನ್ನೊಂದಿದೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಕ್ಯೂ ಕ್ಯೂ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ನೆಗೇಷನ್ ಪಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ದಟ್ ಇಸ್ ವೆನ್ ಪಿ ಇಸ್ ಫಾಲ್ಸ್, ಕ್ಯೂ ಇಸ್ ಟ್ರೂ ಆ್ಯಂಡ್ ಕ್ಯೂ ಇಸ್ ಫಾಲ್ಸ್. ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಜಂಕ್ಟಿವ್ ನೋಡ್ಬೋದು. ಆರ್ ಸ್ಟೇಟ್ಮೆಂಟು ಪಿ ಆರ್ ಕ್ಯೂ ಆ್ಯಂಡ್ ನೆಗೇಷನ್ ಪಿ ಇದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಪಿ ಪಿ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ನೆಗೇಷನ್ ಬರಲ್ಲ, ಕ್ಯೂ ಬರುತ್ತೆ. ಟೊಲೆನ್ಸ್ ಅಲ್ಲಿ ನೆಗೇಷನ್ ಬರುತ್ತೆ, ಬಟ್ ಡಿಸ್ಜಂಕ್ಟಿವ್ ಸಿಲಾಜಿಸಮ್ ಅಲ್ಲಿ ನೆಗೇಷನ್ ಬರಲ್ಲ. This type of problems is very easy. I'll be just explaining 2 or 3. Rest all I'll be saying like that only. If Sachin hits a century, then he gets a free car. Sachin hits a century, so he will get a free car. What you will write? First you assume a statement that it is first he will hit a century, gets a free car. That is the hits a century, gets a free car. 2 conditionals you took. Okay, propositions. What you are saying? If Sachin will hit this, that means P statement you have considered and Q statement. If he will do this, he will get this ಅಂತ ಅಲ್ವಾ. ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತೀರಾ, P ಕಂಡೀಷನಲ್ Q ಮಾಡ್ತೀರಾ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನಿದೆ, ಹಿ ಗೆಟ್ಸ್ ಅ ಫ್ರೀ ಕಾರ್. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್, P ಮತ್ತೆ Q ಅಲ್ಲಿ ನಿಮಗೆ ಏನ್ ಬಂತು, Q ಬಂತು. ಇಲ್ಲ ಅಂದ್ರೆ ನೀವು ಈಗ ದ ಅನದರ್ ಸಿಮಿಲರ್ ವೇ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಡೂ ಐದರ್ P or Q will be what, again Q and the P will be remaining, that is according to modus ponens. Again what you can do here is, see P Q ತಗೊಂಡು ಕಂಡೀಷನಲ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆದ್ಮೇಲೆ he hits a century, so only he will get this free car, right? So he hits a century ಅಂದ್ರೆ ಯಾವ ಸ್ಟೇಟ್ಮೆಂಟು, P ಸ್ಟೇಟ್ಮೆಂಟು. P ಸ್ಟೇಟ್ಮೆಂಟ್ ತಗೊಳ್ಳಿ, ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, Q ಬಂತು ಅಕಾರ್ಡಿಂಗ್ ಟು modus ponens. ಓಕೆ, ಇಟ್ ಇಸ್ ಅ ವ್ಯಾಲಿಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ನೆಕ್ಸ್ಟ್ ನೀವು ಏನ್ ತಗೊಳ್ಳಿ, hits a century P, gets a free car Q. Okay, Sachin does not hit a free car ಅಂದ್ರೆ does not get a free car ಅಂತಂದ್ರೆ ಏನಾಯ್ತು, ನೆಗೇಷನ್ Q ಆಯ್ತು. ಓಕೆ, you here you have to observe negation Q, sorry, yeah, here it is negation Q ಆಯ್ತು. ಯಾಕಂದ್ರೆ he did not hit a century, he does not get a free car. ಸೊ ನೆಗೇಷನ್ Q ಆದಾಗ ನೀವು ಏನ್ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ, modus tollens. modus tollens ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, Q Q ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ನೆಗೇಷನ್ P ಹಂಗೆ ಬಂತು, it is a valid statement. Okay, the same way you will be solving all of these problems, and I will stop up till here. The same type of problems, these were about the statement type problems. If and then if he will study like this, it will happen. So therefore like this happened. Next, just the what, it is like the theory problems. Here next is the like just the conditions they have given, just you have to apply the laws. Okay, that is very easy again, and you can do it. These type of problems is only up to 20-21, and next is about the open statement, quantifier statements and all. I'll be explaining in the next video. And thank you for watching the video. Make sure to like, share, comment and subscribe to my YouTube channel. Until next video, bye bye. And next I'll be uploading even DBMS mod lab 1 program. And thank you for watching the video. Make sure to like, share, comment and subscribe to my YouTube channel. Until next video, bye bye.